Here is a sentence that should not be true, and is. Roughly 1 in 10 of the bright objects that the James Webb Space Telescope sees when it looks deep into the early universe belongs to a category that nobody can identify. Not 1 in 1,000, not some rare curiosity in the corner of one image. 10%. A tenth of everything luminous in that era is a thing we have no accepted explanation for, 4 years after we first saw it. They show up as small red points. They are compact, far more compact than a galaxy that bright has any right to be, in some cases only a few hundred light years across. They appear in enormous numbers, starting around 600 million years after the Big Bang. And then, over the next billion years or so, they vanish from the universe almost entirely. Whatever they were, they stopped. And the specific reason nobody can identify them is not that we lack data. We have spectra. We have deep X-ray observations. We have multi-year monitoring. The problem is the opposite. We have too many clues, and they contradict each other. Every single explanation anybody has proposed solves one property of these objects and breaks another. Every one. For 4 years. These are the little red dots, and in the past few months the argument about them has become genuinely heated, in a way that scientific arguments usually are not in public. Here is what I want you to stay for. First, there are 6 separate things about these objects that are individually strange, and I want to walk you through all 6, because it is the combination that is the real problem, not any single item. Second, a result published this summer suggests we may have been measuring these things wrong by a factor of 100, which would partly dissolve the crisis that made them famous in the first place. And third, there are currently more than half a dozen live competing theories in the literature, and 2 brand new ones landed within the last few weeks, arguing for completely different answers. I am also going to be straight with you at the end about what the title of this video promises and what the science actually delivers, because those are not the same thing. Subscribe if you want more of these. Real papers, real disagreement, and none of the exaggeration. Start in 2022, when Webb began science operations. The first deep field images came back, and within weeks people noticed something in them. Sprinkled across the frames were these tiny, intensely red, extremely compact sources. They did not resolve into shapes. They were points. They were formally cataloged and named over the following 2 years by several groups working independently, and the name that stuck was purely descriptive. Little red dots. Nobody had a better word, because nobody knew what they were. Now, red objects in astronomy are usually not surprising. Something can look red for 2 ordinary reasons. It can be moving away from us fast, which stretches its light toward longer wavelengths, or its light can be passing through dust, which scatters blue light away and lets red through. Exactly like wildfire smoke turning a sunset deep orange. The initial and entirely sensible interpretation was that these were feeding black holes at the centers of small galaxies, seen through a thick veil of dust. Astronomers have known objects like that for decades. If that was right, it created an immediate and severe problem. Because if you take the brightness at face value and work out how much mass you need to produce it, you get black holes of tens or hundreds of millions of solar masses, sitting in place a few 100 million years after the Big Bang. Far earlier than any model said was possible, and far too massive relative to the tiny galaxies containing them. That is the finding that got headlines about the universe being broken, and it is worth holding on to, because one of the results I am going to describe may take it back. Now, the 6 things. This is the core of the video. Anomaly 1 is the shape of the light. If you plot the brightness of a little red dot across wavelengths, you get a distinctive form that astronomers call a V. Relatively bright in the ultraviolet, dipping down through the middle, then climbing very steeply into the red. No standard template of stars, and no standard template of a feeding black hole produces that shape naturally. It has to be engineered by combining components, and the combinations people try tend to look contrived. Anomaly 2 is the emission lines. Somewhere between 70 and 80% of these objects show broad hydrogen lines, with widths corresponding to gas moving at over 1,000 kilometers per second. In every other context in astronomy, that means a black hole. gas orbiting fast in a deep gravitational well. This is the strongest single piece of evidence that there is a black hole in there. Anomaly 3 is X-rays, and this is the one that has caused the most trouble. When gas falls onto a black hole, it forms a hot region above the disk called the corona, and that corona produces X-rays. This is not a subtle prediction. It is a defining feature of feeding black holes. If you have a black hole eating enough to shine that brightly, you should see X-rays. Little red dots are silent. Not slightly faint, somewhere between 10 and 100 times weaker than the standard relationships demand. And this has been tested about as hard as it is possible to test something. A team at the Harvard and Smithsonian Center for Astrophysics stacked together X-ray observations of 55 of these objects in one of the deepest fields ever surveyed. Accumulating close to 400 million seconds of exposure time. Sit with that number. 400 million seconds is more than 12 and a half years of continuous observation combined into a single measurement. The result was nothing. A non-detection. Anomaly 4 is dust, and this is the one that quietly killed the original explanation. If these objects are red because dust is filtering their light, then that dust has to be absorbing enormous amounts of ultraviolet energy. Energy does not vanish. The dust warms up and re-radiates it in the mid and far infrared. That glow is unmistakable, and we know exactly how to look for it. For the great majority of little red dots, it is not there. The infrared emission is flat where it should be climbing steeply. There is no reservoir of warm dust, which means the redness is not coming from dust, which means the simplest explanation was wrong from the start. Anomaly 5 is that they do not flicker. Feeding black holes vary in brightness because the flow of material onto them is uneven. Monitor a quasar for a year and it changes. Teams have now monitored large samples of little red dots across multiple epochs, and the overwhelming majority show no meaningful variability at all. One paper on this has a title I like, about how these things do not twinkle. Anomaly 6 is that they are also radio quiet and undetected in the submillimeter. Now, here is the point of listing all 6. Any one of these has a solution. Bury the black hole in enough gas and you can suppress X-rays. Take the dust away and you fix the infrared. Make the emitting region large enough and you damp the variability. But the fixes fight each other. Add obscuring material to hide the X-rays and it heats up, so now you owe an infrared signal you cannot produce. Remove the dust to fix the infrared and you lose your explanation for why the thing is red. Every model in this field for 4 years has been a game of pushing a bulge from one part of the problem into another. That is what makes these objects genuinely strange. Not any single measurement. The fact that the measurements will not sit in the same room together. So what are the candidates right now? The first serious attempt was super Eddington accretion. There is a theoretical ceiling on how fast a black hole can feed because its own radiation pushes the incoming gas away. But if you exceed that ceiling, the geometry of the flow changes. The disk puffs up, the corona is disrupted, and the object becomes intrinsically weak in X-rays without needing anything to hide it. Several groups built detailed simulations of this. The Chandra stacking result I mentioned was designed specifically to test those models, and the upper limits it produced are deep enough to rule out the current versions. The authors concluded that either these systems are buried under truly extreme amounts of obscuring gas, or, and this is the interesting alternative they raise, the black holes in them are simply neither as massive nor as luminous as everyone has been assuming. Which leads directly to the second thing I promised you. In June of 2026, a paper in the journal Nature took the highest quality spectra available for these objects and asked a very pointed question. We have been assuming those broad hydrogen lines are broad because gas is orbiting fast. What if they are broad for a different reason? There is another way to smear out a spectral line. If light passes through a dense enough cloud of free electrons, each scattering event nudges its wavelength slightly. Do that many times, and a naturally narrow line gets spread into a broad hump. It looks like fast motion. It is not fast motion. The analysis found that in most of these objects, the lines have a narrow intrinsic core sitting inside a scattered wing, which is the signature of electron scattering rather than orbital velocity. And that changes everything downstream, because the line width is exactly what everyone was using to weigh these black holes. Redo the masses with the narrow cores instead of the full widths, and you get black holes in the range of 100,000 to about 10 million solar masses. That is roughly a factor of 100 lower than the published estimates. If that holds, the impossibly overmassive early black holes were never quite as impossible as advertised. We were reading a thermometer wrong. I want to be careful. That paper still concludes these are accreting black holes, and it argues the required densities and sizes cannot be explained any other way. It does not remove the black hole. It shrinks it considerably. Then there is the black hole star model, which has had the most attention this year. The proposal is that the black hole sits inside a cocoon of gas so dense that light cannot escape directly. Everything we see has been absorbed and re-emitted by that envelope, which behaves like the surface of an enormous star. That neatly explains the X-ray silence, the absence of dust, and the lack of flickering all at once, and a detailed spectrum published in June gave it strong support. And then, at the start of August, 2 papers from Harvard proposed something quite different. Their argument is that you do not need a black hole at all. You need a supermassive star. A single coherent object of roughly 100,000 solar masses, which is a class of object theorists have discussed for decades as a possible seed for the first black holes, but which nobody has ever observed. These stars would be unstable and would pulsate. And that pulsation would drive off material that forms the compact shells we appear to be seeing. The team behind it says it is the first model to reproduce so many of the observed properties simultaneously, from the spectra to the shape to the chemistry. They also note, fairly, that even rival models are now invoking supermassive stars as the central engine in some form. Beyond those, the literature currently contains proposals involving bursty episodes of extreme feeding, hybrid models mixing black holes and starlight, and at the more speculative end, primordial black holes formed in the first instance of the universe. A review published this year counts more than half a dozen distinct frameworks under active investigation. So, where does that leave us? There is one more piece worth knowing, because it may be the thing that eventually breaks the deadlock. Astronomers have found an object that looks like a little red dot in most respects, but which is blazing in X-rays. If the cocoon model is right, then these objects should eventually shed their envelopes and turn into recognizable quasars. And there ought to be a transitional stage where the X-rays start punching through. This object could be exactly that. Teams have also reported a small number of little red dots that appear to be evolving into ordinary quasars, and possible low redshift analogs that would let us study a nearby version in far more detail than anything at cosmic dawn. But even that is contested. A prominent researcher at Cambridge has argued publicly that this X-ray object looks to him like an ordinary dust-obscured black hole and nothing more exotic. And there is a fair objection on the other side too. If the cocoon is only just beginning to crack open, why are the X-rays not merely leaking out, but pouring out? Now, the honest part. The title of this video says Webb revealed why the little red dots are so strange. That is true, and I have spent 20 minutes showing you exactly how. What it might suggest, and what a lot of coverage does suggest, is that we now know what they are. We do not. What Webb has actually delivered is a precise and rigorous account of why the problem is hard. It has told us what these objects are not. Not ordinary dusty galaxies. Not ordinary feeding black holes. Not anything in the catalog we brought with us. It has measured the contradictions carefully enough that models can now be killed, which is real progress and is how this is supposed to work. But there is no consensus. There are competing papers being published weeks apart arguing for different physics by serious people using the same data. And I would gently suggest that is more interesting than a resolution would be. Most science communication shows you the finished building. What is happening with little red dots right now is the scaffolding stage, in public, at speed. 10% of the bright early universe turned out to be something nobody had a name for, and the field is openly arguing about it, and the arguments are being settled by measurements rather than by authority. The Chandra result did not care that Super Eddington models were popular. 12.5 years of stacked exposure returned nothing, and the models had to move. What did James Webb actually reveal? That a substantial fraction of the early universe consisted of objects that combine properties which, in every other setting we know of, do not go together. Compact and bright like a black hole, silent in X-rays like something inert, red without dust, steady when they should flicker, everywhere for 1 billion years, then gone. And here is the thing that stays with me. Every one of these objects has been sitting in the sky for 13 billion years. Their light has been arriving at Earth continuously throughout human history. We did not have an instrument sensitive enough to notice them until 2022, and the moment we did, 10% of the deep sky turned into an open question. So I want to know which way your instinct points. A black hole hiding inside a cocoon of gas? Or a single unimaginably large star of a kind nobody has ever seen, doing something we do not have physics for yet? Tell me in the comments, because the people who do this professionally are split, and they will tell you so themselves. If you want more of these, real papers, real disagreements, and the parts where scientists say plainly that they do not know, subscribe. Next time, we are looking at what the first stars in the universe might actually have been like. Thanks for watching.